My friend, I am happy to take a quick trip down memory lane and help us remember all the great things that are a part of standard ESXi networking with standard and distributed switches. All right, the first thing to remember when it comes to the wacky world of ESXi-based networking is that the physical interface is no longer going to be an endpoint like it would be on a physical bare metal installation, a workstation, because in a traditional infrastructure, what do we see? We've got a network interface card, it's got its MAC address, then we place an IP address and run services on top of that. So all the configuration is done essentially directly on top of the network interface card itself. Not so in a virtualized infrastructure like ESXi managed with vSphere. So now in our ESXi representation, we've got a box and it has 4 network cards in the back. So those 4 interfaces are essentially these 4 uplink ports that we see bound to a virtual switch that has been created in the hypervisor of ESXi. Those uplink ports are also referred to as VM NICs. The difference between a VM NIC and a standard NIC is that a VM NIC is not an endpoint, it is just conduit. It is a way to carry traffic, but it's not a way to receive traffic. It's just like the ports on a physical switch. A layer 2 switch are there to carry the end station traffic, but they're not there to be connected to directly themselves. Well, where are the endpoints there? Where do we put IP addresses? We're going to have the world of VM kernel ports. And the way that VM kernel ports work, there'll be a virtualized port on this virtual switch that is bound to one or more of the VM NICs, of those uplink ports. And then behind that port, every VM kernel port also has a VM kernel adapter, a virtual network card. And that virtual adapter will have a MAC address, an IP address, and various services running on top of it, for example, management. But notice that we can create more than one VM kernel port. Here's a vSphere vMotion port. Why would I do that? Well, probably to be able to associate it with other uplinks to divide the traffic up. And then that becomes another virtual adapter behind the scenes with its own virtual MAC address, the assigned IP address, and different services. In this case, vMotion on this interface instead of management on the other interface. What about our virtual machines? Virtual machines are going to connect to the physical network through the virtual switch by a binding of port groups, virtual machine port groups, to those VM NIC uplinks. So as we build virtual machines, they are given virtual NICs, which can be associated with one and only one port group. And they'll be assigned a port in that port group. So each of the virtual machines has a virtual NIC. The virtual NIC plugs into the virtual port group. The virtual port group is associated through the virtual switch with an uplink. And that traffic can still be isolated from one another even though they're going through the same uplink port, because port groups can be assigned different VLANs, as can VM kernel ports, which then can isolate the IP space. So a virtual switch will isolate traffic. That is the job of a switch. And it will essentially do so in groups based upon their VLANs. And then as I have specific unicast traffic, it will do so based upon the destination MAC address. Remember, this is talking about a layer 2 switch. The MAC address table is not built dynamically, though. It's just based upon the virtual NIC MAC addresses stored in the ESXi table. So what about scalability? With a standard switch, every ESXi system that needs to have a similar configuration will need to be manually configured. With equivalent virtual switches created, virtual machine port groups and VM kernel ports associated with that virtual switch, uplink ports associated with it, and you can see we have a very trying process, which is why with the enterprise license you can create what's known as a distributed switch. That distributed switch is created in vCenter as a centralized object, and then deployed out to each ESXi host, which has its own physical adapters, which then get assigned as specific distributed uplink ports. So essentially the physical ports have to be bound to the vCenter distributed switch template as it gets deployed. But now, if I've got 3 or 30 or 300 ESXi hosts, as soon as they receive this distributed switch and the ports are associated, then we immediately have the correct port groups that are needed with the associated VLANs. We have the VM kernel ports created and associated immediately. And then as I vMotion a particular VM to one of those ESXi hosts, and on the old system, it was a part of the production port group. When I bring it over to my new ESXi host, it's immediately in the right network. The distributed switch also has a bunch of other services that are associated with it. Things like being able to perform mirroring to a management console or IDS environment. We have advanced logging. We can forward information to a NetFlow service. But the key thing to see right now is just the fact that the distributed switch allows the ability to have a scalable infrastructure when it comes to deploying our core ESXi networking. But here's the caveat. So looking at this example of ESXi A, B, and C, we have a consistently deployed distributed switch on all of these. Uplink ports are associated. Life is good. Now, can a virtual machine in test dev access another virtual machine that's also in test dev? Maybe test dev has been configured with VLAN 500. Well, the answer is maybe. What would be required for a VM in test dev on ESXi-B to talk to a VM on ESXi-C? And that would be that the intermediate physical switch network support VLAN 500. That has to be configured. We got to go talk to the physical network admin guys and make sure VLAN 500 is actually configured correctly. And that's a good start. But what about our folks that are connected to test dev on ESXi-A? My friend, the VM that's tied to test dev up here on ESXi-A can never reach the VMs that are in test dev on ESXi-B and C. And that's because this requires routing. And routing requires that the IP space, let's say it's a subnet like 10.1.1.0/24, that either has to be on the left or it has to be on the right of this router. It can't exist in both directions. And yet that's exactly what we're saying is going to happen. Now, none of these are flaws. It's simply understanding the limitations of what a standard and even a distributed switch can do in our physical network. Well, my friend, by having this vSphere networking brought to the forefront of your mind, you're going to be able to embrace what's new in NSX networking. I hope this has been informative for you, and I'd like to thank you for viewing.